Hi everyone, how are you doing today? This is Lakshmikant from KJP Talkie, and today we are going to tear down Qwen 3.8 Uncensored model. Yes, you have heard it right. Today we are going to tear down uncensored model, and also we will tear down the base model as well. We will compare what is changed inside the uncensored model, how actually you convert a base model in uncensored model. All these we are going to look in this particular lesson. So let's get started with this. First of all, let me tell you which particular uncensored model I'm using in this particular lesson. So I'm using an uncensored model from Orc Router. So Orc Router has given us this uncensored model for Qwen 3.8, and they have given this in various bit format. I selected Q4KM. So this is the most, the famous 4-bit quantization technique, generally, which is also used by the Ollama as well, and also in Unsloth it is also available. So we will be using this particular model. All right, now let's go ahead and see how I did this benchmarking of uncensored model and base model. So as I told you, I took Qwen 3.8 27 billion parameter model first, that I say as a stock model. All right, I took this stock model from the Ollama. Apart from the Ollama, I also took this from the Unsloth as well. All right, so I took it from two places, Ollama and Unsloth. And then also I took this uncensored one from the Hugging Face from the Orc router, as I told you earlier. All right, now let's go ahead and see how this uncensoring is done in large language model. So there is a technique which is known as abliteration technique. All right, so when your uncensoring is being done for a particular model, that technique is known as abliteration. In abliteration technique, what happen actually, you edit a particular set of weight in your large language model. Once you edit a particular set of weight in large language model, then its refusal behavior is gone. For example, let's say if you have a various set of the vectors in your large language model, v1, v2, v3, and so on, then what happened? Only a particular set of vectors are responsible for a refusal behavior. You just edit those vectors, thereafter this refusal behavior is completely gone. So what we have done in this particular tutorial, actually what I did here, I downloaded the stock model and also I downloaded the uncensored model. Thereafter I compared both model together architecturally, and also I compared their weights as well. Thereafter I found there, out of 866 vectors, there were many vectors which actually got changed, and those changes were made in a systematic way. They were not random at all. That is something which we will be exploring in this particular lesson as well. But before that, let's go ahead and see what setup I used for this particular benchmarking. So I used RTX 5090 with 32 GB of VRAM, and I used here the llama-server on Windows 11. I'm sharing all these information with you so that if you want to reproduce the same result, you can also do that. Apart from that, one thing you will notice, I have downloaded the stock model from the Ollama, and also I downloaded the stock model from the Unsloth as well. All right, and this is the uncensored model. So I compared this uncensored model with the Unsloth one, and also I compared this with the Ollama model as well. Now I'll tell you why I needed to do that. But before that, let me just tell you here a little bit more detail so that you can understand about the model. Okay, cool. So here at the Qwen 3.8 stock size, what you are seeing here, so what numbers you are currently seeing, this number is coming from the Unsloth and plus Ollama. So what happened here, I downloaded model from Unsloth and Ollama. That is not a censored model, all right? That is not the uncensored one. That is the stock model which is provided by the provider itself. Thereafter, I found no changes at all between, no changes at all between the models. But if I compare these two models with the uncensored one, which is coming from the Orc router, then I see here a few changes. Most of the changes, most of the things are exactly same. There is no change at all. But finally, I saw here a few changes. Thereafter, I dig it deeper. But before that, let me just tell you here where you need to put attention. So this is something where you need to put attention. 866. All right, remember this number. This is something which we will use later on. Apart from that, also remember 5120. All right, so this is something which you need to remember. These are the most important term which we will be using later on to refer. Okay, so 866 tensor vectors are there in the GGUF file, and then the hidden size, that means the internal representation of the text data or the large language model, is actually represented in 5120 dimensions. So this is the most important part. Apart from that, you will notice file size is almost similar. There is no change at all other than very small and the minor change. And you will notice here weight values. So between the Ollama and Unsloth, there is no weight value. I mean, there was no weight value change. But if we compare the Unsloth Ollama with the uncensored one, I got to know that 131 tensors got rewritten actually. Okay, out of how many? 866. That is why I told you, remember this name, 866. Okay, so out of 866 tensors, 131 tensors were rewritten. Now the question is here, what are those tensors? Okay, and how they got written? So those things I'm gonna discuss here. Okay, so before I go deeper, I need to explain you here. All these tensors which you have here, they are actually arranged in block. All right, so 866 tensors. How many? Let me just write it again. 866 tensors, and each of these tensors are actually represented here 5120 dimensions. So this dimensions means this is a vector space. Okay, cool. Now this 866 tensors are coming from different block. Okay, so they are coming from the attention output, they are coming from the SSM output. This is like a linear attention output, linear attention state output, and this one is a full attention state output. You know, the feed forward neural network is there, the token embedding layers is there, and then you have feed forward neural network gate, and then the attention query key and value vectors, you know, the attention query key value projection vectors, and so many other stuffs here. Okay, so there are so many blocks. Wherever you are seeing this purple one, they are saying this is where you know, the uncensored model weights got modified here. Okay, so they were modified in this block, attention block and linear attention block, and the fully connected neural network block. And also there was a single layer, I mean there was a single block in which this token embedding also got modified. That's all. And by combining all these, we had total how many? 131 vectors out of how many? 866. Okay, so out of 866, 131 vector actually got modified. Apart from that, one more thing I want to tell you here, this line which you are currently seeing here, this dotted line, all right? So dotted line says here 0.0032. So this is like, you know, the base standard deviation, which I'm considering to make sure if anything above this, I mean, if any weight deviation between the uncensored and the stock model, if any weight have a larger deviation than this one, then we say that that particular direction is actually, I mean, that particular model weight is modified. And we can see here, this is the base. And if we compare here, then they are like, you know, much larger than the standard deviation. And they are not actually random. You will see here, they are done in a systematic way actually. So before I deep dive here, you will notice here how many blocks are there. So there are total 64 blocks. All right. So there are 64 transformer blocks, and then plus one MTP block is there. So there are total 65 blocks. Okay. So out of these 64 blocks which you have here, you are going to see here in this attention output, there are 17 full attention block which actually got modified here, here, and here. Okay. So out of four, out of four actually one block got actually modified here. So if we consider here 4 block, out of this 4 block, this got modified, and then in next 4 block, this got modified, and so on. You can clearly see here, this is very much systematic, and there is, you know, the pattern here you can find out. Similarly, in a linear attention neural network output, I mean linear state output, linear attention state output. So there you can also find out here, out of 4, 3 neural network, I mean out of 4, 3 block weight got actually changed here. So also 3, 3 and 3, everything is here, in a quite symmetric way. Similarly, in a feed forward neural network block, they also changed 65. They also changed overall, the 65 tensors there total out of these blocks. How many tensors were there? Total, we had 866 tensors. Now, if you combine all these together, you are going to get here almost 130, and then plus 1 is coming from the token. So these, what is being shown here to you, they come like 130, and then plus 1 is coming from the token embedding. So their total 131 tensors actually got modified. Now the question is here, what they modified in this? That is very important. Okay, so let me just explain you. So all these tensors which you are currently seeing, 866 tensors, they are actually projected into a 5120 direction. That means that is the vector space in which our data is getting represented. But obviously we cannot display this 5000 the dimensions in a 2D surface. What we can do here, we can actually represent here a two-dimensional vector for time being, let's say. Okay, so these are the x and y. Let's say this is y, and here you have the x. All right, so you have x and y, these are the two dimension, and let's say you have here some vector. Okay, and you see that, okay, this is the vector dimension which is actually trying to do the most of the refusal. So what you do in uncensoring, you actually remove these vector dimensions at all from your vector. Okay, so this dimensions direction which you are currently seeing here, this got removed. So out of 5120 dimension, there was one dimension in which this refusal was there. All right, so this refusal was coming from one dimension, and that dimension actually got removed. And how I verified that? So let me just show you how I verified that. So you will notice here, I actually calculated the direction of all the vectors, all modified vectors, actually 131 modified vector. Then I found that all those vectors are actually pointing in the same direction. Their similarity is very high, 0.9970. All right, 73. So basically 0.99 to 88, almost they are similar. So basically you can see that they are almost similar. Whereas if I tested the similarity of the input projection vector, then their similarity is quite less. So with this, I identified, okay, there are 131 tensors there which got modified because they were going in a particular direction which was actually causing the refusal. Okay, great. Now I hope you have understood here how it is happening overall. As I told you earlier, so 17, the 17 the tensors got modified from the attention output neural network, and then 48 got modified from the attention linear attention output block. Thereafter 65 got modified from the feed forward neural network, and then one got modified. So this one, let me just see here. So this one actually got modified from the token embedding. And if you combine all these together, thereafter you are going to get here 131 total tensors out of how many? Out of 866. Okay, great. Now I hope you have understood this properly, that how this uncensoring was done. Now let me just show you the result here, how actually they performed here. Okay, cool. So what I did here, after understanding that how this uncensoring was done, thereafter I did the benchmarking over the uncensored model and stock model. Why benchmarking was needed here? Because I wanted to understand whether refusal is removed or not from the uncensored model. So what I did there, I took a 15 harmful prompt across the weapons, drugs, cyber, bio, self-harm, crime, hate, and disinformations, and so on. All right, so these were the sections, including the pornography and the child pornography. Okay, and thereafter I took the 15 benign harmful prompts as well, but they are benign. Actually, they are not much harmful, but they are actually the catchy one. For example, question related to how to kill the Linux process. So there you see there the word kill is coming, something like that I took. So basically there were total 30 prompt, 15 prompts were the harmful one, and 15 were a benign harmful. Again, here the definition of harmful is again subjective. I did not go, you know, in that much strength of the harmfulness basically. So I kept it like so kind of things in the harmful. I did not go in the deeper. So I just took that okay on the surface level so that I can identify that whether the refusal is happening at all or not. That's all. Okay, cool. So what I did and what I found here that was really very interesting. So what I found actually, so stock Qwen 3.8 model refused actually how many? 6 prompts only. Okay. Whereas uncensored build refused the 11 prompt. Okay. But this is wrong. Why wrong? Actually what happened, uncensored one did not refuse it. Actually uncensored model got out of the token budget. Okay, I'll explain you why it got out of the token budget. But thereafter I tested it again with the fix. Then I found out that uncensored build did not refuse on any of the prompt. That means seems like 100% refusal got removed from the uncensored model. Whereas this Qwen stock Qwen 3.8 refused 6 prompt only. Okay. Now the question is here, why that token budget got, how the tokens got out of the token budget. So the one thing I noticed here in uncensored model, which is literally quite alarming to me. So uncensored model actually kept thinking. So do you notice here that uncensored model thinking budget is quite high. Whereas this stock model was giving us the result with very less thinking token. Okay. So seems like after removing that refusal direction, actually what happened, uncensored model starts thinking more as compared to the stock model. Because of that, we saw that out of those 15 prompt, almost 11 prompt actually got out of the token budget. Otherwise, when I checked their thinking trace, in the thinking trace answer was already present there. That means uncensored model did not refuse any prompt. Basically the answer was there, only issue was that there actually uncensored one thought too much. Because of that it gone out of the token budget. Okay, apart from that, what I did here, I actually tested this with the proper benchmarking as well. So where I tested this uncensored one and uncensored one and the stock together. So I found that overall on normal question, basically not a harmful question, so accuracy was okay, there was no issue with the accuracy. So I got 20 out of 20 in the stock Qwen model, 20 out of 20 in uncensored model as well. Thereafter in perplexity, so perplexity is like how consistent the output is there. I also saw that here the stock and uncensored model were giving us the proper result without any issue, and there was no issue in the speed as well. MTP off was giving us a speed like 70 to 80 token, which is normal, which we have already seen many times. And when MTP was on, then for a particular set of the problem, it was giving us the overall token speed like 100 to 120 token per second. Okay, again this is quite subjective related to the type of the content we are writing. That is something which I have already covered in my previous videos. If you have not watched on my channel, go ahead and watch that. I have covered all these in the very detail, that how this token generation speed affects by the content type. Okay, great. So now I hope you have understood that what is the difference between the uncensored model and also the stock model. And I want to just tell you here how actually I used this uncensored model with the Ollama as well. So this is what I did with the Ollama. Mostly the mostly the benchmarking was done with the llama-server, but I just wanted to test it with the Ollama as well. So this is how I actually created my model file in the Ollama, and then I loaded it, and thereafter I also did chat with this particular model on the Ollama chat, Ollama, the chat window. I saw that this model was really good. Overall, I did not see any kind of the refusal. I tested various kind of a prompt, including almost all aspect of the harmfulness. Obviously I'm telling all these because of the learning purposes only. So I just wanted to tell you how these uncensored models are actually getting the modified from the stock models actually. Okay, so out of in fact in all these process, what I saw there, that there was no post training, there was no fine tuning, there was no LoRa weight update and so on. There was just the model weight edit in a particular direction, and 131 tensors were edited, and then finally we got the uncensored model. All right, now I hope it was very much clear to you and you have understood the difference between the uncensored model and the stock model. Apart from that, I wanted to share here that I have been doing this tear down and benchmarking since quite some time. I have published so many videos on my channel. Please go ahead and watch other videos as well. And also please do not forget to like this video and subscribe this channel. And if you have any questions to ask, please do not forget to ask that question in the comment box. I read each and every comment and I reply also each and every comment. All right, guys. Bye bye. Take care.